Hello student of class 10th, once again we are here with a new video, and in this video we are going to learn the Cartesian sign convention of the mirror. And before this video we had learned about the ray diagram, the position of object and the images formed by the concave and convex mirror, uses of convex and concave mirror, definition related to mirror, spherical mirror like pole, center of curvature, principal axis, focal length, principal focus. All these things we have to revise. Now in this video we are going to discuss about the sign convention. So if you see this diagram, the mirror, this is a concave mirror, and if you see the object is here, the object plays on the principal axis on the left side of the mirror, and the light always come from the object. You remember this thing, the light is always come from the object. So the direction of incident light is from left to right, and the distances are measured from pole. All the distances we measure from the pole. So the distances measured opposite to the light is taken negative, and the distances taken in the direction of light are taken positive. So this is the rule, as we had seen in the maths, also in the coordinate geometry, if you had learned that chapter. So if you draw the perpendicular axis x and y, so where the x and y cut, that is origin. On the right hand side of the x we are taking x positive, on the left side of the x we are taking x negative, on the upper side of the axis we are taking y positive, and below the origin we are taking the y negative. Like this also here, if p is the origin, if we suppose p is the origin, so right side of the p is taken positive, left side of the p is taken negative, above the principal axis is taken positive, and below the principal axis is taken negative. So by this also you can learn the sign convention. So what is sign convention? Object is placed left to the mirror and pole is taken as the origin. Distance to the right of the origin is taken positive, while that of left is taken as negative. And distance above the principal axis is taken as positive, and the distance below the principal axis is taken as negative. So this is a sign convention, Cartesian sign convention, very important while solving the numerical. When you are going to solve the numerical of the related to mirror, so you have to use this sign, and how to apply this sign you will learn when you solve this numerical, but it is very important to learn this thing. Now the next is mirror formula for the spherical mirror. In this mirror formula you see we are using the term V, U and F, and the mirror formula is 1 upon V plus 1 upon U is equal to 1 upon F, where U is the object distance we are taking from the pole. So distance of the object from the pole is taken as U, distance of image from the pole is taken as V, and distance of focus from the pole is taken as F, small f, called focal length. So 1 upon V plus 1 upon U is equal to 1 upon F. This is a mirror formula. And if you see the object in the case of convex mirror, it is on the left side of the mirror taken as negative. In the case of concave and convex both, so you see the object always it is negative in both the cases, concave or convex mirror. V in the case of convex it is positive, but in the case of concave it is positive and negative depending on the position of the object where the image formed. In the case of convex mirror the focal length is positive, and the case of concave mirror the focal length is negative. So this is the very important you have to keep in mind while solving the numerical. So you see, if you compare, the U is always negative in the case of concave and convex both. V is positive for convex and positive or negative for concave, and F is positive for convex and F is negative for concave. So this is very important relation, and according to sign convention you have to learn this thing. The next is magnification. Magnification is the ratio of the height of image to height of object. Means what the object we have taken and what the height of image is there. Suppose image is bigger than the object, we can say the image is magnified, and if the image is smaller than the object, we say that image is diminished or it is less magnification. So magnification is denoted by small m, and it is equal to height of image upon height of object, that is h2 upon n1. h2 we are taking the height of image and h1 we are taking the height of object. Or we can say image distance upon object distance, that is minus v upon u. It is the formula, it is a relation for magnification in the term of height of image, height of object, and the term of image distance and object distance. So h2 upon h1 is equal to minus v upon u. For virtual image, m is positive, and for the real image, m is negative. If m is negative, if you are solving the numerical and if m is negative, so that means the image is real, and if m is positive, it means the image is virtual. And if m is greater than 1, the image is bigger than the object. If m is equal to 1, image is of the same size of the object, and if m is less than 1, the image is smaller than the object. Means while solving the numerical, if you see that m is more than 1, so you can write the image is magnified. If m is equal to 1, the image is of the same size of the object, and if m is less than 1, so we can say that image is smaller than the object. So you have to keep in mind the mirror formula, the magnification, the sign convention, and while solving the numerical you have to apply this. So when I give you the numerical for this related topic, so you have to solve according to the sign convention. And very important, remember this thing, whatever you are going to find, suppose you have to find the focal length, you have to find the image distance, you have to find, and suppose anything you have to find, so for that you are not going to keep the sign. Whatever the thing is given, for that only you use sign, and for the content whatever you have to find, you have not to use sign in that. Means whatever the sign will come, that will be in your answer. You are not going to put your sign by your own. So revise this thing, revise the topic again and again, apply on the concept, apply on the question, and any problem related to this topic, you can call me, you can message me on the group. Till then, thank you. Have a